Hi, my dear students. Our lesson today is about the quadrilaterals. Let's remember what the meaning of quadrilaterals. We know that we have some shapes. We call the polygons. Polygons like triangle or triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, and so on. Okay. So the quadrilateral is a polygon which has 4 sides, 4 angles, and 4 vertices. Let's see some examples of the quadrilaterals. First, parallelogram. Okay, do you know the shape of parallelogram? It's like this shape. Okay, we know that it has 4 sides, 4 angles, and 4 vertices. Okay, let's see what is the properties of parallelogram. Parallelogram each 2 opposite sides are equal in length. Each 2 opposite sides are equal in length. يعني the 2 sides which opposite to each other equal in length. If it was 5 centimeter, this will be 5 centimeter. If it was 3 centimeter, this will be 3 centimeter. Okay, each 2 opposite sides are equal in length. Okay, and we have another property. Each 2 opposite sides are parallel. Parallel. Do you remember the word parallel? Parallel means never intersect. Parallel means never intersect. So each 2 opposite sides are equal in length and what? Parallel. And parallel. So we can say this side is parallel to this side and this side is parallel to this side. Okay. Number 2, the diagonals. Do you know the meaning of diagonals? I think it's the first time to hear about the diagonals. Diagonals, it's a line segment which joining between 2 opposite vertices. Diagonals is a line segment which joining between 2 opposite vertices. This is diagonal and this is diagonal. In the parallelogram, the diagonals not equal. Not equal. If it was 6 centimeter, this will be maybe 4 centimeter. Okay, not equal. Not equal. The diagonals not equal. But the intersecting point divided each diagonal into 2 equal parts. This part will be equal to this part, and this part will be equal to this part. Okay, so if the diagonal length here was 6 centimeters, so this part will be 3 centimeter, and here will be 3 centimeter. If the diagonal length here was 4 centimeters, so this part will be 2 centimeter, and this part will be 2 centimeters. So the diagonals in the parallelogram not equal, but bisect each other. But what? Bisect each other. What's the meaning of bisect each other? Bisect each other means divided each diagonal into 2 equal parts. Into what? 2 equal parts. This part equal to this part, and this part equal to this part. But the diagonals not equal. Okay. Number 3, what about the angles? Okay, the angles of the parallelogram, each 2 opposite angles are equal. Each 2 opposite angles are equal. And this angle will be equal to this angle, and this angle will be equal to this angle. Okay, what about the angles of the parallelogram? Each two opposite angles are equal. Each two opposite angles are equal. We call this two angles opposite. Opposite angles, okay? And these two angles, opposite angles, okay? Okay, these two angles, the blue one and the black one, not equal. But what is the relation between them? The relation between them is the sum of these two angles. We call them consecutive. The sum of two consecutive angles is 180. Why we call these angles consecutive? Because they come after each other. Okay, like these two angles are consecutive, and these two angles are consecutive, and these two angles are consecutive, and these two angles are consecutive. So the sum of two consecutive angles equal 180. Okay, so we know that. Let's remember the properties of parallelogram. Number one, each two opposite sides are equal and parallel. The diagonals not equal but bisect each other. Keep this property well, because all the diagonals in all shapes bisect each other. Okay, each two opposite angles are equal in measure. The sum of two consecutive angles equal 180. And we consider that parallelogram is like a father of all quadrilaterals. Parallelogram is like a father of all quadrilaterals. So every property in parallelogram exists in all quadrilaterals. Okay, but with some difference. Okay, let's see another shape. Number two is the rectangle. Okay, the rectangle is like a parallelogram, is one of the sons of parallelogram. Okay, so we said before, every property in the parallelogram are exist in exist in what? In the other quadrilaterals. Okay, so the first one, each two opposite sides are equal and parallel. Okay, and parallel. Okay, what about the diagonals? The diagonals here. Okay, we know that we have common property, bisect each other. But here, in the rectangle, what about the diagonals? Equal or not equal? Let's think. Okay, it will be equal diagonals. Why? Because we have equal angles. Equal angles. Equal angles. Okay, this angle equal to this angle, equal to this angle, equal to this angle. If the all angles are equal, so the diagonals are equal. But the diagonals in the parallelogram, in the rectangle are equal, and we know that's a common property and bisect each other. Okay, what about the angles? All angles are equal in measure, and it's a type what? Right angle. Okay, so can we say that the rectangle is a parallelogram with which a or with a with one right angle? Okay, with one right angle. One of you may ask me about we have four right angles. Yes, because if one of these angles is right angle, so the others will be right angles. Okay, why? Because we said that this angle is right, so the opposite angle will be right. Okay, and we said also the sum of two consecutive angles equal 180. So if I subtract 180 minus 90, it will give me 90. Okay, so all angles are equal in measure, and it's a right angle. Okay, let's see another shape, the square. Okay, The square has all properties of parallelogram. Okay, we know that each two opposite sides are equal and parallel. But here, not opposite sides are equal only. We said that all sides are equal. We know that the square has 4 equal sides. So all sides are equal in length. Okay? Okay? And I can say also each two opposite sides are parallel, so all sides are equal in length. What about the diagonals? Okay, we have a deal that if one of the angles was right angle, or if the shape has equal angles, so diagonals are, yes, very good, are equal. If if all angles are equal in measure, so the diagonals will be equal. Okay, so the diagonals will be equal in length. Okay, so the diagonals, what about the diagonals? Equal in length, and we said that we have common property. Yes, bisect each other. Okay, and I have another property. And perpendicular. What's the meaning of perpendicular? Do you remember the meaning of perpendicular? Perpendicular means the intersecting between them makes 4 right angles. Okay, so we have here one right angle, and here right angle, and here is right angle, and here is right angle. So the diagonals equal in length, bisect each other, perpendicular. What about the angles? Right, like a rectangle, equal in measure, and its type is right angle. Okay, let's see the rhombus. The rhombus, like a square, in all sides are equal in length. Okay, but let's see. What about the angles? All angles are equal? No. We have this property here. We have each two opposite angles are equal. So the diagonals will be equal? No, the diagonals not equal. But the common property, bisect each other. And perpendicular. And what? Perpendicular. Okay. So each two opposite angles are equal in measure. Okay. If the sides are equal, so the diagonals will be perpendicular. Okay. Let's think what is the common property between the rhombus and the square. Rhombus and the square, all sides are equal. Okay. The difference between them, the diagonals not equal. The diagonals not equal, and the angles not right angle. Okay. The last shape is the trapezium. The last shape is the trapezium. What about the trapezium? It has only 2 parallel bases. Let's see this game complete with right or wrong. Okay, I'll say the property, then you can tell me is this property exist in this shape or not. Okay. 2 opposite sides parallel and equal. Of course, we know that all shapes, all the quadrilaterals, or this family, parallelogram, rectangle, square, and rhombus, all of them, each 2 opposite sides are equal and parallel. Okay, trapezium, no, because it has only 2 parallel bases. All sides are equal. Let's see. Parallelogram, no, not all sides are equal. Rectangle, no. Square, yes. And rhombus, yes. And trapezium, no. Diagonals bisect each other, yes. We said that it's a common property, but in trapezium, no. Diagonals are equal. We said that if we don't have equal angles, So the diagonal is not equal. In parallelogram, no. But in rectangle and the square, yes. Rhombus, no. Trapezium, no. Diagonals are perpendicular. Okay, diagonals perpendicular. Okay, parallelogram, no. Rectangle, no. Square, yes. Rhombus, yes. And trapezium, no. Why we said that the square and rhombus only has perpendicular diagonals? Because all sides are equal. Okay, two opposite angles are equal. All of them two opposite angles are equal except trapezium. All angles are right. We know that we have two only shapes has right angle, square and rectangle, and the other not. Okay, let's see Classwork booklet page 45. First, complete. The polygon which has four sides is called, we know that the name is quadrilaterals. Each two opposite sides are parallel in all shapes. Each two opposite sides are parallel. Parallelogram, rectangle, square, and rhombus. Okay, each two opposite sides are equal in length in all shapes also. Parallelogram, rectangle, rhombus, and the square. The four angles are right angles in rectangle, and the four angles are right angles. We said that square and rectangle also. The two diagonals are equal in length and bisect each other. Two diagonals equal and bisect where rectangle and square. The two diagonals are perpendicular and equal. So one shape square. The two diagonals are perpendicular in square and rhombus. In the square, all angles are right angles. Sorry, in the square, all angles are equal in measure, and all are equal in length, and all sides are equal in length. The rectangle is a parallelogram in which one of its angles is all angles are right angles. Thank you.